When I was 9 years old, I watched NASA shoot a rocket off in search of Pluto. And when I was 18, I got to see the amazing photos of that dwarf planet that resides on the edges of our solar system. In between those years, I watched as the technology around me rose up to astounding levels. It was incredible what we could make to improve our lives. And there came a point when I believed that there was nothing that technology could not do. And then I discovered this. This is the emerald ash borer beetle. It's believed to have come from eastern Russia on wooden packing pallets, and it was first discovered in America near Detroit in 2002. This beetle attacks only ash trees, or trees within the Fraxinus genus. It does its damage by the adults boring into the bark of the tree, leaving these D-shaped exit holes. And what they do, once the adults are under, they lay their eggs, and then the adults go on to nibble along the foliage of the tree. But that's not the part that does the damage. The part that does the damage is the larvae they leave behind. When the eggs hatch, the larvae starts eating its way up through the cambium layer of the tree. And this is the part of the tree that delivers nutrients. So once this is compromised, the tree dies. There's nothing you can do to stop it. And then the larvae grows into adults, and they fly to the next tree, and the cycle repeats itself. And now this sounds like a very specific problem because they only go after ash trees. But white ash trees make up our forests. Our black and our green ash trees are crucial to our wetland ecosystems. Losing these trees means losing entire communities within our forests. According to the United States Department of Agriculture, this beetle is now in 27 different states and has cost the United States almost $11 billion in both economic and environmental damage. Many attempts have been made to stop the spread of the beetle at the tree. Scientists have hung purple boxes that hang in the canopies. You might have seen them around before. They're laced with something called manuka oil, which is an enticing oil to the beetle, and it acts as a fly trap, trapping the bug inside the purple trap. Another thing they've tried to do is release parasitoid wasps at the site of an infestation tree. These wasps are trained to eat only the emerald ash borer. And these sound like incredible ways to go after the beetle at the tree. But the problem is the beetle only moves half a mile a year on its own. And the life cycle of a tree is so long that we don't yet know if the boxes or the wasps are actually causing a negative impact on their population. The problem is we don't have that much time. The beetle is already spreading to different countries. It's in Europe, it's in Canada. It's in Rockingham, Hillsborough, Belknap, and Merrimack counties in New Hampshire. So how are they getting so far if the beetle only spreads half a mile a year on its own? The problem is us. We chop down our firewood, we buy little bundles of chopped firewood, and we bring them camping. We bring them to places like Franconia Notch. Specifically in New Hampshire, we bring them to the Loudon Motor Speedway. People come to camp and they bring firewood from all over the place, and there's no way for anyone to know if it's been treated or not. There's no way to know if the firewood is infested, and people are unknowingly giving free rides to invasive species, allowing it to spread so quickly. So while scientists are working on a way to attack the beetle at the tree, how can we stop the man-assisted spread? What can we do now to slow that down? What about dogs? We already know that the nose of a dog is exponentially more powerful than anything we know about. And that's partly because of how our noses are built. This is the human nose. It's comprised of our nostrils, and when we inhale all these different molecules of odors, and they run back over our scent receptor cells, back into the yellow bulb on the slide here. And that olfactory bulb is the epithelial area that delivers the odors to the part of the brain that processes scent. And basically, the more scent receptor cells you have, the better you are at smelling. Humans have around 5 million scent receptor cells. But the German Shepherd has 225 million. As you can see here, the dog's nose, the muzzle is so much longer, allowing for so much more space for olfactory receptor cells. You can see here this cutout of the yellow. That is their olfactory bulb. It's a labyrinth, it's a maze of a surface area that's dedicated to sending these odors to the part of their brain that processes scent. And dogs have a brain where 40% of it is dedicated to processing scent alone, which is magnitudes larger than what ours is. Another really important thing that dog can do is when they smell, they can inhale and they can separate their air into 2 different pathways. One goes down into their lungs, allowing them to continue to breathe as they work, and the other sends all of those odors, all those concentrated chemical compounds, straight back over their olfactory cells and into their epithelial area in the back of the olfactory region. So why aren't we using dogs for conservation? We already know that they can scent out drugs, they can find explosives, they can find other illegal contraband, they can smell things up to 40 feet underground. We do not have a piece of technology as powerful as a dog's nose. We are incapable of creating a piece that matches the power of the nose right next to me. So why aren't we using them? This is Rue. She's a 5-year-old working German Shepherd, and I've had her since she was 8 weeks old. I was still in middle school. I've been working with her every day for 5 years. And the first thing I noticed about her when I got her was that she had a nose. She went after every scent, and she had the drive to follow it. Many years ago, I asked my little brother if he could hide behind the shed so that Rue could find him. And I watched. It was a beautiful summer day. There was no way for him to leave any visible footprints, and anyone not watching would have had no idea where he was. And I watched as he took a step, and then he turned, leaving a footprint that no one could see. And then when I let Rue go and I asked her to find him, I watched as she searched frantically with her nose in the air, and she was inhaling all these molecules and chemical compounds that we can't even fathom, and then suddenly her nose dropped to the ground, right on his footprint. And I watched her nose go from footprint to footprint, and then turn exactly where he had been. And within 30 seconds, she had found him. So, when the time came for me to graduate high school, I had to do a senior project. And I knew that I couldn't do it without Rue. An amazing dog trainer, Dee Ganley, introduced me to the idea of dogs working for conservation, maybe scenting out the ash borer and infested firewood piles. So what I will show you today, is how Rue can scent that out. In front of me are 3 boxes. One of them is infested. 2 are colored green on the bottom, and those are the clear ones. The other is red. And what I'm going to show you is how she is trained to alert to that. And what she will do is she will either sit or lay down when she finds it. And that is called a passive alert. She's got to stretch first. She's got to get ready. Yep. All right, Rue, are you ready to work? Are you ready to find bugs? Yeah? You ready to find bugs? All right. Now I am going to cover the mic up a little bit because it throws my voice out and it can distract her. Ready? Sook. 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 Is that it? Show me. Sook. Good girl. And this is the red one. As you can see, that took Rue all of 30 seconds to tell me that that was the infested piece of firewood. So why aren't we using dogs at places like the Loudon Motor Speedway? Why aren't we using them to intercept moving firewood? This would allow scientists more time to attack the beetle at the tree and decrease their population. If we had well-trained working conservation dog teams at checkpoints, we would be able to slow the man-assisted spread of the beetle incredibly easily, and we would be able to save our forests. And the thing is, technology is incredible. It really is. But this is the tipping point. Sometimes it's okay to step back and think, what you're already looking for might already be here, and they might just be in the forms of our best friends. Thank you.